Okay, so today we're going to talk about class libraries, packages, and then give, there's a nice example with this random class. So just understand how Java uses packages to organize code. Remember that from the beginning, I've emphasized that all of your classes should be in a named package. And that's because just as Java uses packages to organize its code, your code and the user code, library code is best organized, again, using packages. Oops. My mouse keeps, okay, so excuse me. And then kind of know what import does and doesn't do. So because of this package organization, there are some subtleties that are associated with the fact that Java didn't name the import thing very well. So, all right, so let's talk about class libraries. So a class library is a collection of classes that we can use when developing programs. So the one that we're going to be using is the Java standard class library. See, Java's organized in kind of two pieces. There's the core language itself, which consists of things like the compiler and the Java virtual machine. And as we've mentioned, the compiler takes source code and turns it into this intermediate form called bytecodes. And then the Java virtual machine takes bytecodes and then turns them into native executable program and then executes it. But that's the core language, and the core Java language is actually fairly small. But it has something called a standard class library, and that's part of any Java development environment. And the standard class library is actually separate from the core language itself. But we rely on it because in order to get anything done, you need to use these classes. So we've already seen classes called system. Again, that is a class, system, scanner, and string. And these are part of the Java standard class library. And the Java standard class library is huge. One of the ironies is that when Java first came out, in contrast to existing popular programs like C++ was the dominant one at the time, but it was huge. And Java came out, and one of the things that it was touting was that it's small and you can do a lot with this little small thing. Well, over time, all that has been basically tossed aside. So Java is not small anymore, it is huge. Well, however, the core Java language itself is very small, but in order to do anything, there's this Java standard class library, which is huge. And in order to do a lot of the tasks that typically come up, we will often have to use third-party libraries. Now, in this course, we probably won't have a chance to look at that. Those of you who will be taking the discrete event simulation course, that's a follow-on for this, we will be using at least one standard class library, or not standard, one third-party class library that introduces simulation classes. So, but that's all part of the next quarter. But sometimes it's referred to as API. That's a standard acronym. And I know that as military officers, you very rarely encounter acronyms. So this may be a little bit of a shock to you, but API stands for Application Programming Interface, and that's just sort of a fancy name for these classes that we refer to specific APIs. So for some of the standard ones, there's the Java FX API and the database API. Although something interesting happened since our textbook was published, and Java went through some changes. If you have noticed that when it comes to writing user interfaces, the book uses something called Java FX. And at the time the book was written, it looked like the Java FX was the preferred library to be used for creating graphical user interfaces. Since then, what Oracle did was they took Java FX out of the standard class library. So it is no longer the quote preferred one, although it's still available as a third-party library. So I've been sort of debating about how to present that. We'll be talking about user interfaces later in the course. We will be using not Java FX as the textbook says, but we'll be using one that's in Java itself now called Swing, but that's all for later. When it comes to using databases, what Java provides, it provides an API for the database, but typically, in order to connect to a specific database, you will need a third-party driver. So, for example, databases that I've used include, I've played a little bit with Oracle, but it's a little bit heavyweight. But MySQL, again, one of the popular open source databases. My favorite one these days is something called SQLite. Again, that requires a specific driver, which is freely available. There's Microsoft Access, which can be interacted with Java. Again, it's a little bit clumsier than some of the other ones, but it can be done. Anyway. Okay, so the Java API. One of the really nice things about Java is that it has the documentation is also embedded in the code itself and can be used to generate HTML pages that describe what is going on with that class. So if you want to find out information about the class, you don't have to look at the code. You only have to look at the Java doc API documentation. So for example, let me show you an example here. Okay, so now this doesn't always work from NetBeans. So here's the, come on. All right, so here we use the scanner, and if you're interested in what is the API for scanner, if I right-clicking on it and I say show Java doc, and what that does is that opens up the HTML page for scanner, and now I can see the documentation for what scanner does. So in this case, they have a very extensive comment section here, that this is all HTML comments that is in the code for scanner itself. So in fact, I can show you that by, if we say navigate to the source, then here is the scanner class, and all those comments are in the Java comments here. And if you'll notice, the syntax is just standard HTML, and that produces a web page that looks like this. So in addition to all this other stuff here, it also lists all of the, and this is the API here. This lists all the constructors. It lists all the methods. So you can see that there are a lot of methods in Scanner that we haven't really touched. So for example, has next, and we can give a little pattern. And this pattern is something called a regular expression that we'll talk about later in the course. But things like, in the assignment, we were just kind of reading in the integer, but if you notice, what would happen if you typed in something that wasn't an integer, like a string or a floating point number, well, then it would just sort of bomb out. But we could query it and say, is the next thing an integer or not? So that's another. You can see that there are a ton of methods here. There are just a ton of methods in this. And how can we find those out? Well, and we can also look at, let's see, in this particular case, there are, we're going to talk about what some of these are later, but what this says is that scanner is a direct subclass of object and that it implements these three interfaces. What does all that mean? We will get to that later in the course. Okay, so the online, and this is all online. Like when I clicked on that, it took me online to see the documentation. And as you notice, that's there. We can see everything in the package as well. And we can look at the overview. And this lists all of the different packages that are in Java. Because we just came to the page itself rather than the top of the API, it didn't. Oops, where are we here? If you come into the right page, then it lists the packages and then all the other kind of stuff there. So it's a very, this was something that Java, I think they stole it from some other language. They actually stole a lot of things from other languages. Not that they were patented or anything, but Java really made the idea of this documenting very popular. And see, now here's the thing. Again, let's kind of look at this here. Here, the Java doc for the class, in this case, I just had a very simple one, but this can be turned into pages, HTML pages. In fact, if we say generate Java doc, it will actually do that for us. So here's the Java doc for assignment 1. And see that this was the short comment that I had there. And basically all we had was just a main method that didn't have anything else. But the point is that this, that's why Java doc comments are preferred, because the other comments are not put into this HTML. Okay, so let's dive into what packages are about. So we've been using packages since the get-go. Again, the CS2173 package is something that we insisted on. And the idea is that especially when you have a huge number of classes, then you want to organize them. Instead of just having them all in one big blob, you typically want to have them organized. Just as on your computer, you don't just put all of your files in one folder or on your desktop, although sometimes it looks that way. So a Java lang, okay, that's all the standard stuff. And when you use a class from Java lang, then you don't have to worry about imports, which we'll talk about in a second. But here are some other packages. Java util, util stands for utilities. So these are some utilities that are common helpers. JavaNet is another package for network communication. Again, these JavaX ones are not in the standard library anymore, so just be aware of that. Instead, there are ones in JavaX, not JavaFX, JavaX .swing is what we will be using instead. And so swing is actually, that was the kind of the older one. JavaFX was some I suspect some folks at Oracle that had decided that they didn't like swing. And so with some good reason. There were things in Java FX that were actually more nicely done than in swing, but swing was, I program mostly in swing myself when I use user interfaces, and I'm fairly comfortable with it. And after this class, you will be comfortable with it too. Okay, so let's talk about import. Now, you may have, in the last assignment, we used this scanner class that was not in the standard class Java library. Because it was not in the standard library, we needed to either import it or use its fully qualified name. Okay, so that's why I said import. This was something that was generated by NetBeans. Okay, remember, if we kind of leave this out and we just say fix imports, then NetBeans puts it back in. All right, so NetBeans went and found it and then used the import statement. Now, here's the thing to understand about it. The import statement doesn't import anything. Okay, so that may seem a little strange, and it is. All the import statement does is it allows you to use, when we're using a class like scanner, all it does is if we have this import statement, then we can use scanner just by itself. Okay, so here's the thing. The name of each class is the package name together with the class name. This is this that I've underlined right here. This is the actual, no kidding, name of the scanner class. And if we were to look into the byte codes that were generated, that's how it would be depicted. The thing is that's a if you're writing expressions that use that's a lot of noise. And so just to be able to skip this part and refer to the class as scanner, which is referred to this is called the unqualified name. The unqualified name of a class is just its full name. The fully qualified name is the whole thing. This is the fully qualified name, and that's the actual, no kidding, name of the thing. Now, they say that you can use the star. You can use the star. Again, this is that is not recommended. So don't do this. Okay, now here's the thing. That we don't need to use the import at all. Remember, I said import doesn't do anything. So let's say for our scanner, say now here, notice I'm getting the red squiggly here, can't find it. If I type in the fully qualified name, everywhere I use it, notice the red squiggly goes away. And now I can actually run this and it'll work just as normal. So you notice that's why I'm saying the import statement doesn't import anything. All the import statement does, and let's, one of the things, we can revert our modifications on this. And we're back to this. All this import statement does is it lets me use scanner without having to write the full qualified name. That's what the import statement does. So it's just pure convenience for not having to do a lot of typing. And again, it does not import anything. And that's in contrast to other languages like, well, in Python, the import statement actually imports things. In C, the term was include, and the include statement actually included things. So that was well named. In Java, the import statement is not well named just because it doesn't import anything. So just understand that. Okay, so again, anything in the Java lang package is imported automatically. So that's why we didn't have to import system or string or any of the other ones. Scanner, we had to explicitly either import or use the fully qualified name. And again, you should never use this star thing. Okay, so let's talk about the, just as a specific example, the random class. It is also part of the Java util, and it generates pseudo-random numbers. In the simulation course, we'll talk a little bit more about what is meant by pseudo-random. Just in brief, on the computer does not generate any truly random numbers. It is literally impossible. What the random object does is it basically produces a stream of seemingly random values. Okay, so here's an example. So this is from the book. So we have a generator. We instantiate it from random. Again, they use floats. We should use doubles, but we'll. Okay, so if we want a random integer, that's that's kind of between 0 and the maximum value of an integer. So that's generally not very useful. This construct is generally more useful because that, okay, again, we have this off by 1 business. So if I say next int 10, that will produce a random integer from 0 to 9. Again, why? Don't ask. Okay, so if we want one from 1 to 10, we simply add 1 to it. If we want one from 20 to 34, again, we can sort of see that. So the fact that we can only next int produce it with an integer upper bound produces a value between 0 and 1 minus that upper bound, we can then adjust it to have any ones that we want. Okay, now they're using floats. I would use doubles instead, and we'll see. So the next int, notice the random integer, that's between 0 and the maximum value of an integer. That's usually not very useful. These tend to be a little more useful. The random float, again, should be a random double. We'll show you an example. So what is produced by these? So what range of values? So next int would produce something between 0 and 24. That's a 2. Okay, next int 6 plus 1, that would be between 1 and 6. Okay, 110. So that would be, this would be between 0 to 99. And add 10 to it, so that would be between 10 and 109. So this is between 0 to 49. Add 100. And this would be between 100 to 149. Okay, this would be between 0 and 9. Minus 5, it would be between minus 5 and 4. And
Professor, what would generator be classified as? Is that a object?
Yes.
And then next int is the method?
Exactly. So yeah, so let's look at this. Okay, yeah, so random is the class, generator is the object, and it's instantiated as one of these. And then when we do something like this, we are invoking a method. So we have object dot method. Okay, good question. Okay, so an expression that produces a random integer in the following ranges. I think that's fairly straightforward. Okay, so let's see an example of this in action. So oops. Yeah, now, okay, just to illustrate something, notice I put a comma in here, and NetBeans is very helpful here because it's as soon as I put that comma in, it says, oh, no can do. You cannot use a comma in defining a class name. And just by the way, this, if you're wondering where your files are, when we create it, this kind of tells you exactly where it is. So if you're kind of wondering about it, so all right, this is the gobbledygook. All right, so so now here's the thing. Let's and again, just to kind of emphasize how things like this go, when you when you're just a piece of advice, when you write a line of code and you get the red squiggly, then stop, don't write anything else until you've resolved that red squiggly. Okay, so it cannot find symbol. And then actually, if you notice, sometimes there are like little yellow light bulbs to the left. And so if we click on those, we can actually see some options. And there are actually 3 options that it presents. So we can either add the import, and that's a possibility, or it says, hey, if you want, you can create your own class, and we can put it there, or we can actually put it inside this class. That will create what's called an inner class. We're going to talk a little bit about inner classes later in the course, so we don't need to worry about that. So for now, when you get a red squiggly like this, then you can add the import either from there, or you can simply right-click anywhere in the text and say fix imports, and it will fix the imports. Okay, now, and it turns out random actually has 2 constructors. One has no arguments, and then the other has a long, which is the seed. And I'll show you what the difference is. So let's generate. Okay, so what I'm going to do is I'm going to okay, we haven't talked about the for loop yet, but I'm going to show you one anyway. Okay, so and again, in this class, at least, floats are verboten. Always use doubles. And I know the book uses floats sometimes, but they get to because they wrote the book. But since I'm the instructor, I get to. Okay, so what I did here was I'm simply generating these guys. And what are they? These are uniform between 0 and 1. Next floats also do the same thing. So when I say next double, what that does is that generates a value between 0 and 1 randomly. Now, here's the interesting thing. Let's save that and oops. Okay, so I wanted to save the values because when I run it again, I get different values. So here, these were the values that I had first. Notice that I'm getting different values here. So why is that? Every time I run it, I'm going to get different values. That's because when I use the 0 argument constructor, it sets the seed from the clock. Now, in certain contexts, that's okay. Actually, for using randomness in analysis, such as simulation, that's actually not a good idea. So instead, what is a preferred way is to give a specific seed. And what this will do is this will produce exactly the same values every time. Okay, so let's save those values. And then if I run it again, I'm going to get exactly the same values. So no matter how many times I run it, then I get exactly the same values. We can check that, see? Why? Because I set the seed explicitly. A couple things here as well. The seed, it was expecting a long value. So to show that a constant is meant to be a long, I put an L afterwards. Now, Java lets you put a lowercase l, and it won't complain. But uppercase L is preferred. Do you see why? Is it clear why uppercase L is preferred if I'm specifying a long constant?
Might confuse it for a 1.
Exactly. The L and a 1 are almost indistinguishable, whereas here, this L, I mean, is absolutely, the L cannot be mistaken for any particular number. Okay, now the other thing is that what they can produce is a next Gaussian. And you've all had, you know what a Gaussian is, right? Gaussian is it's another word for the normal distribution. And it's called Gaussian because it was invented by Laplace or discovered by Laplace. Don't ask me why, but Okay, so now a standard normal distribution, if you remember, has a mean of 0 and a variance of 1. And so if you'll notice, it generates, in this case, it's going to generate the same values every time, but some of them are negative. And that's to be expected because the Gaussian distribution produces values that are both plus and minus. So, for example, here's how, supposing we wanted to just sort of test that. Right, so here, instead of just printing them, I'm going to add them to a sum. And then actually another way to kind of do something like this. Yeah. Because every time I want to do one of these, I can do the sum and then I can now do the average, which is going to be the sum over the count. Okay, and I don't have to worry about casting this because sum is already a double, even though this is a count. And if I wanted to be doubly sure, I could cast this to a double. Again, when you're doing something like this, this makes, remember we talked about programmer intent and also belt and suspenders. So this just makes absolutely clear what I was trying to do. And so when I run this, we see that the average it's kind of close to 1. If we just do a whole bunch more, then, okay, we get an average that's kind of cool. Again, because it's somewhat random, quasi-random, pseudo-random, we're not going to get exactly the same values each time.